picked a couple of questions to practice on after section 3.1. These are both from your exercises at the end of the chapter. The first one is number 18 from section 3.1, and it says, suppose we're constructing a confidence interval using repeated tests of significance, so hypothesis tests, to develop an interval of plausible values. Using two-sided tests each time with the following null hypotheses, we obtain the resulting p-values. Part A says, using the results from the table, give a 90% confidence interval for pi. So first of all, we need to figure out the value of alpha. So 100% minus 90% equals 10%. So that means that alpha is 0.1. That is 10%. But remember that alpha we normally write as a decimal. So now I have to compare p-values in the table to this alpha value of 0.1. And if the p-value is less than the alpha value of 0.1, I will reject the null hypothesis. If the p-value is greater than 0.1, I will fail to reject, which means the H0 pi value is plausible. So I look at my first p-value of 0.014. Of course, this is in fact less than 0.1. So I'm going to reject this null hypothesis value. 0.032 is less than 0.1, so I will reject the value of 0.46 for pi. It's not a plausible value for pi. 0.062 is less than 0.1, so I'm going to reject 0.47 as not being plausible. But 0.126 is bigger than 0.1. This 0.48 then is a plausible value for pi. 0.376 is bigger than 0.1, so 0.49 is a plausible value for pi. And notice, as I work my way down now, the p-values are getting bigger and bigger and bigger, so they're all greater than 1, plausible, 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 plausible. 0.142 is bigger than 0.1, so pi equal 0.56 is plausible. But then 0.077 is less than 0.1. 0.57 is rejected as not being plausible. 0.042 is less than 0.1. 0.58 then is rejected as not being plausible value for pi. 0.021 is less than 0.1. 0.003 is less than 0.1. So I'm rejecting the corresponding pi value. So that means the 90% confidence interval. So our first plausible value is 0.48, and our last plausible value is 0.56. So 0.48 to 0.56, and I write it that way in parentheses separated by a comma. That is the 90% confidence interval. So the end points are the 0.48 and the 0.56. Then part B says, using the results from the table, give a 95% confidence interval for pi. So the 95% confidence interval, again, we have to find the alpha value. 100% minus 95% is 5%, which means the alpha value is 0.05. That is the decimal equivalent of 5%. So now I'm going to compare the p-values in the table to 0.05. And if the p-value is less than 0.05, then I'm going to reject the null hypothesis as not being plausible. If the p-value is greater than 0.05, I'm going to fail to reject the null hypothesis. So the pi value in that null hypothesis is plausible. So I go back up to the table and I look at the 0.014, and that is less than 0.05, reject. 0.032 is less than 0.05. I'm going to reject 0.46 as not being plausible. But 0.062 is bigger than 0.05. That means 0.47 is a plausible value for pi. 0.126 is bigger than 0.05. This is a plausible value, 0.48, etc., etc., etc. I get to 0.142. That's bigger than 0.05, so I have a plausible value in 0.56. 0.077 is bigger than 0.05. Let me just try to squeeze that in a little bit better there. 0.077 is bigger than 0.05, so now 0.57 is plausible at a confidence level of 95%. 0.042, on the other hand, is less than 0.05, so we have a reject in 0.58. And the rest are rejects as well. Each of those p-values is less than 0.05. So my first plausible value at the 0.05 significance level, or the 95% confidence level, is 0.47, and my last plausible value is 0.57. So the 95% confidence interval is from 0.47 to 0.57. And note to self, this 95% confidence interval is wider. Just going to write that a little bit better. The 95% confidence interval is wider than the 90% confidence interval. Or you could say the 90% confidence interval is narrower than the 95% confidence interval.